Artificial intelligence has been around for years, for decades. A lot of the AI methods that we use were invented in the 70s, the 80s, the 90s. So it's really just the fact that we're at the point in time where we have the computational power that we can really take full advantage of these. And this is why a lot of AI approaches, particularly deep learning and neural network approaches, have really exploded.
It's very powerful. It really takes us to another level. Because of the time it takes to process data like this, we will increase the frequency so we can understand what's happening at a much faster timescale out in the ocean, and I think that's really exciting.
PML is in a really nice position in that we've got a lot of data, we've got a lot of experts who can analyse the data, and we've also got technical skills in using AI and working with these big data sets.
PML work with the European Space Agency and with NASA, and we gather massive amounts of satellite data from them, but we also go out and do a lot of field work. So we collect data from drones, we collect data from cameras mounted on the fronts of ships. One of the projects we worked on was looking at harmful algal blooms, where we used satellite imagery to try and match that up with people taking samples at stations. Various different organisations were sampling at different locations all across the channel, and then we were able to capture any time where there was harmful species of algae. We then matched that up with satellite imagery, and then we trained an AI model to detect when there are cases of harmful algal blooms occurring. And this is quite important for understanding the impact that it might have on aquaculture, particularly with shellfish. It can make shellfish harmful to eat.
Plankton are a group of organisms that combine plants and animals and are incredibly diverse with hundreds of thousands of different species. They populate marine environments and they also populate freshwater environments. What I've noticed over the 30 years of worth of data we've got for the Plankton Time series is there are subtle changes happening, and we need higher frequency data to really understand how these patterns are changing. So currently we collect samples at sea and we bring them back to the lab to process via microscopy, and this is very time consuming with a current rate of about 1 sample per day. But we're now moving into automatic imaging systems, and we have a system, the imaging flow cytobot behind me. We'll be able to sample every 20 minutes and that data will then come back to us, so we will increase many times fold the amount of data that we can generate.
So there's an invasive species of Pacific oysters that has been spotted along the coast of Devon. So a couple of my colleagues went out and did some drone flights where they flew drones over a series of sites where these oysters have been spotted. And then another one of my colleagues sat down and manually annotated and identified about 7,000 oysters. It's quite time-consuming work. The advantage of this is now that we can train a machine learning algorithm. So in this case, we used a few different algorithms. One of the algorithms we used is called YOLO, which is a neural network approach where you can identify individual objects within an image. So we took this data, we trained a pre-existing model. So this model already had an understanding of drone imagery, and then we specifically taught it, this is what an oyster looks like. We want you to find all the oysters and count them within this scene. What that means now is that we can fly that drone over a series of sites and it will automatically identify and pick out all the different Pacific oysters over that site.
We have a large high-performance computing system at PML designed for AI. It's called Maggio, so the massive GPU cluster for Earth observation data. And that's something we operate through a service called Neared Asset PML, so that we make that available to others. And we combine our expertise in applying the algorithms to large data sets to work with researchers so they can scale up their algorithms to large data sets or develop new models.
As a scientist, I'm really excited by this technology. It means that we can link up and we can have a much better collaboration so that we can understand not what's happening just in a local area, but we can extrapolate that to the globe because there are different patterns happening in different areas.
There's so many good opportunities at PML at the moment for AI. There's so many different science areas which are rife for AI to come and interrupt the way that we traditionally do science and see if there's more that we can try and extract from data that people have been collecting for decades. Really, it's about trying to gain more of an understanding and a deeper understanding as to what's happening.